Okay, so here's the video for section 9.2 translations. Again, we've already talked about translations before. That's basically when you just move an object. You don't twist it, you don't turn it, you don't flip it, nothing, just move it. Now, um, we've worked with vectors before, and now we're going to come back and bring them back into the place to describe translations using vectors, because before we just said, here's a translation, here's what it is. Now we're actually going to say, how do we create them? So the first way to do it is to use a translation vector. So translation is a function that maps each point to its image along a vector called the translation vector. So again, here's the pre-image original figure, here's the image, and it moves along a vector. That's the translation vector. And the two considering characteristics of this are that each segment joining a point in its image has the same length as the vector, and this segment's also parallel to the vector. Okay, so point A goes to A prime, parallel and the same distance as vector K. And so here's a little kind of a drawing of that. Hopefully this shows up nicely on your screen, but I've got this vector here of vector u, and this is the computer program's way of saying it. It's 2, 1. That means right 2, up 1. They just don't have it in like the bracket notation like we do. This is another way to write vectors as well. This is saying go right 2, up 1. That's the vector I'm translating along. Here is how this guy moves. And if I want to go to left, then I just scroll this so it's negative 2 to the left. And now what's happened is it's still going up 1 because I haven't changed that, but now it's going left 2. And this vector here is the same length as this vector, same direction, they're parallel. And then if I want to change the up or down movement, I just change if this vector here goes up or down, and that forces this one to change as well. Okay. So first example, just to kind of talk through in the book, like how to draw one. If you wanted to really draw a translation using your compass or a straight edge, the first thing you have to do is copy the vector. So I've got this vector W here, and what I do is I figure out a way to find the length of it and its direction, excuse me, and then each point, G, H, J, and I would just draw that over and over again, copying that vector. And what happens is when I do that, those new endpoints from I to I prime, that becomes the new endpoint for that segment, endpoint for that one. The way they did this is that G went to H, that's where G prime lands, and then H goes up here to H prime. So all of them move along this exact same vector right here, which can I kind of sketch with that? Let me try this. That's kind of copied. So now if I copy this guy, and I just don't move him, here's how I get, well, that's actually not quite right, is it? Those vectors aren't the same size, but they travel along parallel vectors. Yeah. Okay. So, yeah, here's first, here's the next part. As well as creating a translation vector, there's also a formula for it using coordinate notation. It's really simple. Basically what it amounts to is they have this x, y, and x plus a, y plus b. Well, really what's happening is this guy right here, this 7, 4, 7 is a, 4 is b. So that's how we get those points. So again, the horizontal is a, vertical b. And if it's positive, that means horizontal we go to the right. If it's negative, it means we go to the left. If it's negative for or positive for the vertical, it means we go up. If it's negative for the vertical, it means we go down. And it ends up being really easy to do. All we did was we took negative 2 and added 7 to it. We got 5. Added 3 to 4, we got 7. But this whole time I'm translating along a vector that's 7 right, 4 up. So we go. Okay, so here's the book's first kind of example of this. They tell us to translate this along a vector of negative 3, 2. That means just go left 3, up 2. Okay. And all of these guys will do that same exact movement. Left 3, up 2. Left 3, up 2. And when I do that, then I get this figure right here, where they all went left 3, up 2. Now the way to do it, the formula is then just to take all the x values, subtract 3, take all the y's, add 2. 6 minus 3 is 3, 2 plus 2 is 4. 5 minus 3 is 2, negative 5 plus 2 is negative 3. Okay, so here's the first example for you. We've got ABC with those vertices. We're going to translate it along the vector of negative 1, 3. So the question is, which one of these 4 points or groups of points would this become now A prime, B prime, C prime? Okay, so let's take a look. Just going to use the formula for it real quick. Whoops, I keep moving that up. I don't need to. Here's what I need. So in order to do this, what happens is I have to take all the x values and add 3. So, add -1, because that's what the horizontal is. Take all the y values and add 3. Okay. Do the same thing for b prime. Same thing for c prime. Okay, and do all that. And now I'll get my a, b, and c prime. So a prime will become -4, 1. B prime will become 3, 7. And I'm going to get a space. C prime will become 2, 0. So looking for the one that has -4, 1, 3, 7, 2, 0, and then ends up being D. Okay. All right, so that was that example. Okay. Next one, rain problem here. The question in this one is the graph shows repeated translations as a result in the animation of a raindrop. So I guess when you're making a raindrop on a computer, you could tell it to translate along a vector, and it would give you this drawing. And the question is, which one of the translations would get me from position 2 to position 3? Okay. All right, so looking at from position 2 to position 3, which one would give us this? Well, let's see here. To get from position 2 to position 3, we're starting at the point 1, 2, and we're going to end up at -1, -1. Now, some of you are pretty quick to say, okay, well, I had to go, you almost just kind of map it out. You say, okay, well, to go from -1 to 1, from 1 to -1, that means I have to go left 2, and then to go from 2 to -1, I have to go down 3. And so that's a vector of -2, -3, or in coordinate notation, x, y, arrow, x -2, y -3. And that's fine with me. What the book does, though, is they'll kind of set up a formula. They say they know it's x to y is x plus a and y plus b. So they'll just replace 1 with x and say 1 plus a has to equal -1, and they solve for a by subtracting 1. Oh, a is -2, which is what we got. And then the same thing would say, okay, well, this is y plus b. Well, y was 2, so 2 plus b had to yield -1. Okay, so what would b have to be then? -3. So the book likes to treat it kind of an algebraic way. I treat it in a much more natural way of like, we went left 2, down 3. That's where we went. So either vector -2, -3, or x -2, y -3 is the coordinate. Okay. Okay. And then next example. It's just examples, running through those to kind of knock everything out. So the graph shows repeated translations that result in the animation of a soccer ball. So choose the correct translation of the soccer ball from position 2 to position 3 in function notation. Now that's what they call this. This is called function notation. So here we go. All right, so let's take a look here. So from position 2 to position 3. Again, I'm not going to do the algebraic way. I'm going to do the kind of counting way. To go from 2 to 3, I had to go right 3, down 2. Which means then x, y, 2, x, the new one, I have to add 3 to x and subtract 2 from the y. And we'll see if one of those works out. And it does. They kind of treat it, though, with this kind of incomplete form of it's D. We'll do x plus 3, which we have, and then to do y plus -2. That's fine. It's kind of weird they did this. Normally they just go right to y minus 2, but plus -2 is the same thing as -2. Okay, and then last example. From 9.2, the graph shows repeated translations that result in the same thing. Now they want to do 3 to 4, but using a vector this time, so instead of the coordinate notation. Okay. So 3 to 4 drawing wise, again, just kind of sketch it out. We went right 2, down 2. So our vector for that is positive 2, negative 2, which is C. Okay, so that's section 9.2.